Okay, let's talk a little bit about assembly hierarchy. Now let's approach this first from the bottom up. Okay, so we'll assume that you started by creating a part as you've been doing so far. Now you're going to bring that part into, let's call it a container, which is going to be the assembly container. Okay. Next thing you're going to do is create more parts and add them to your assembly until some coherent whole is accomplished. Okay, something that fulfills a particular function. We'll call that a sub-assembly. We're going to continue that process and perhaps make different sub-assemblies, and then we're going to propagate those, in other words, put those sub-assemblies together into higher level sub-assemblies. Then we're going to continue that process of part and sub-assembly creation until we rise all the way to what we will call the top level assembly, and that's going to be our ultimate goal, for our design effort. Okay. Again, a bit of terminology. Every time you add a component and then repeat that component, so say for instance, this very typical example would be fasteners. Okay, you're going to need more than one fastener, because I will think of that as a component, but then you need 10 of the same kind. We're going to call those instances. Okay, and similarly, when you have sub-assemblies, if you have multiple sub-assemblies present in a top level assembly, we will refer to those again as instances of that particular sub-assembly. Okay, so this is all from the bottom up. Let's look at it now from the top down. Okay, let's look at this beautiful picture here of this Airbus A350 and think of it in terms of how we would create a hierarchy, this time going from the top down. Okay, so you can imagine, okay, at the level of the aircraft, that would be our top level assembly. What sub-assemblies, what major sub-assemblies would be apparent to us in here? Well, clearly there's going to be a sub-assembly here for the airframe. Okay. The airframe in turn is going to have multiple subcomponents in it. For example, the wings, the fuselage, the empennage, the tail section, etc., etc. Okay. We might also find as a subassembly the propulsion system for the airplane. Okay. So of course that speaks to the engines, and then the engines in turn are going to have a series of subassemblies, on down, to individual parts. That ultimate component that cannot be any subdivided any further, right? Okay, then similarly with the avionics, with the maybe the hydraulic systems and pneumatic systems, HVAC systems, flight controls, all manner of different electrical, electronics, etc., etc. So all those are going to belong to respective subassemblies and then on down to the individual part level. Okay, so here you can see what that might look like, for our example. Okay, so aircraft at the top, then airframe, propulsion, controls, hydraulics, and avionics would be the first tier subassembly. Within airframe, we're going to have a fuselage. We could call it a subassembly. Okay, and then similarly for the wings, and then the wings also have various control surfaces there, such as ailerons, spoilers, and flaps, and then each one of those in turn is going to consist of a number of sub-assemblies. Of course, we don't repeat the sub, we just call them generically all sub-assemblies until we get all the way down to the part level. Okay. Now, this applies for something as big as an airplane or maybe as small as this power pack in here. And hopefully we can, by now, train our eye, to readily recognize, what would be logical sub-assemblies here if we were to undertake the design of this particular component. So a logical sub-assembly, for example, here might be the sheet metal that makes up the frame of this device. We would also have certain connectors in there as sub-assemblies, and those connectors would in turn be made up of plastic inserts, of threaded bodies, of fasteners, pins, etc. There are some other connectors in there, some plastic connectors that would themselves be sub-assemblies. Then we might look at the printed circuit board as its own subassembly, and then on top of that subassembly you would have different discrete components such as capacitors, resistors, coils, connectors. We see there are ribbon cables connecting various parts, relays of some manner. If you were to break the relay or treat the relay as a subassembly in itself, then you would have the external plastic casing. Inside there would be a coil of some manner with a winding, with different types of connectors, soldering points, moving parts. If this were to be solid state relays, then you would have again, a circuit board inside with multiple components that have been potted and encased in some manner. We see there are fans as well, and you can imagine again the fan can be subdivided into discrete components, perhaps even discrete subassemblies. Okay, so hopefully it's clear to us that the concept of a hierarchy is valid, is what we encounter in real life, and this is precisely what SolidWorks makes available to us. And here's an example of exactly that. So here within the SolidWorks environment, we see a barbecue grill. If you were to look here on the left, you would find all the components and different subassemblies that make up the top level assembly. Okay. So the top level assembly is named full grill assembly. Okay. Then notice, okay, unlike having features as we normally would have at a part level, what we have instead, what we find, at least at this layer, is various parts that make up the top level assembly. Now notice there the icon that only has yellow in it with the inverted T, well, that would be the icon for a part. Now the icon that has also the additional green item in there, that indicates that this subcomponent is in fact an assembly itself. So if we hit on the plus, if we extend that, we'll see that that subassembly is in turn made up of different parts. Now only when we drill all the way down to individual parts do we need start rather to recognize the features that we're familiar with from creating parts. Okay, so notice again that we have a top level assembly being composed of either individual parts or their own subassemblies, and then those subassemblies can in turn include other subassemblies. And then finally you get down to some part that is no further subdivided, and then you see its individual features. Okay. Now this process is only limited really by computer memory. Okay. You can navigate down the assembly hierarchy as deep as you need to in order to represent your top level assembly. Now we're going to find out very soon here how to create these assemblies, how to bring in the parts, how to establish relationships between them, and how to create these hierarchical trees that we've just examined in this example in the grill. Before we do that, there is one item that comes up very, very natural in the context of assembly, and that in fact has parallel in other areas of engineering such as solid mechanics, dynamics, rigid body dynamics in particular, and that has to do with the concept of degrees of freedom. We'll look at that here in the next video lecture.